Now, today we will be doing continuity of functions and discontinuity of the functions. Okay, functions, first we say a function is continuous. A function is continuous when left hand limit is equal to right hand limit is equal to the the value of the function. That is the that means limit x tend to a minus, that is left hand limit x tend to a minus, that is left hand limit minus, and this is x limit x tend to a plus fx is equal to the right hand limit, and this is called functional value. So how do I get the functional value? I put the suppose a is there, I put it in the function. So now this is called a function is said to be continuous, and it is for anything, any three. Suppose if left hand limit is not equal to right hand limit, then it is not continuous. If left hand limit is equal to right hand limit, not equal to functional value, then it is also then discontinuous. Then here we will discuss 2-3 functions, that is sin x. Sin x, cos x, etc. are all continuous functions. Sin x, what is the graph of the sin x? Sin x is fx is equal to sin x. The graph will be, it is that sin 0 is 0. Sin pi by 2 is 1. So maximum, the upper limit is 1, and then comes again sin pi is 0, again sin 3 pi by 2 is minus 1. So on, it will never be discontinued. Okay, similarly the left hand side, it is sin minus pi by 2 is minus 1. Sin then it is sin pi is, this is sin pi pi by 2, and this is sin pi this is 0, again 0 here. So therefore sin x is fx is equal to sin x, then fx is equal to sin x, then it is a continuous function. It is a continuous function. It will never break. Never it will have a discontinuity. Now, cos x, we will be dealing with cos x. Okay. Fx is equal to cos x. Let us remember the values of cos. For cos 0, 0, cos 0, 0, cos 90, cos 90 is cos 0 is 1, cos 90 is 0, cos, again this is here, that is we take in along with y-axis, and this is along with x-axis. This is x dash, and the value of the angle we will take this, and the value of the function will be here. The maximum it will go 1, and minimum it will be minus 1. Here, have you noticed that sine is oscillating between 1 and minus 1? Sine is oscillating between 1 and minus 1. Similarly, cos is also oscillating between 1 and minus 1. That is, here is, so we will find out its range. We will here, this is here, we will find out with the range. Then comes fx is equal to y is equal to x, or fx is equal to x. Now here this is a function. This is a function x that is x-axis, and this is y fx, and this is also fx here. the this angle will be fx, and this is the graph of fx is equal to x. 1 is equal to 1. See, look here. 1, if you put it here, 1, fx is equal to, then it is value of 1. Then x is equal to 2. Then fx is equal to 2. Then x is equal to 3. Fx is equal to 3. If x is equal to minus 1, then fx is equal to minus 1. So it will be straight line, and this is degree 1 linear equation. So it will be a straight line passing through 0. That is origin. What is origin here? See, look here. Origin 0. Fx is, if I put fx is equal to 0, then then value will be 0. Okay. So here also 0 it takes. If I put x is equal to 0, sine 0 is 0. Cos 0 is 1. So the 0 value here it is taking 1, and here it is taking 0. So sine is oscillating between minus 1 and 1. Cos is oscillating between 1 and minus 1. That is 1 and minus 1 here. So it is a wavy curve. It will never be discontinuous. 3 curves I have shown you that it will never be a discontinuous curve. Have you noticed? Similarly, that discontinuous curve, if I want to tell you what is discontinuous curve. Discontinuous curve, suppose here this is a discontinuous curve, that is, here it discontinues sometimes, that is, here I will just draw the figure. The discontinuous curve, if, look here, if fx is equal to, if now it is sin x, cos x, etc. continuous function we have written. Acha, now if limit x tend to minus 1, x tends to minus a minus fx, and is not equal to limit x tend to a plus fx. That means left hand limit is not right hand limit. Left hand limit is not right hand limit. Implies immediately I can say that the function fx is discontinuous. Similarly, this is the first point. Second is that if it is limit x tends to a, fx not equal to the functional value of a, not equal to the functional value here, not equal to the functional value, implies again it is that the function is implies function is fx is discontinuous, is discontinuous. So we can say that is if I write this is limit extends to a f x, that means both side limit plus minus. Okay, then it is not equal to a, that is functional value. This is called functional value. Then the limit is not continuous. This is discontinuous. Okay, then I write, suppose they are limit extends to a minus 1, that is a limit extends to a minus and fx is not equal to one of the left hand side limit or right hand side limit, fa, or limit extends to a plus fx not equal to fa, immediately I can say that the implies fx is not continuous. Fx is discontinuous at a. Fx is discontinuous at a. Continuous at x is equal to a. So now we will be dealing with the sums. Now have you followed? This is that limit continuous function is all are equal. That is left hand limit, right hand limit is equal to the functional value. And the discontinuous is, that is limit fx minus left hand limit not equal to right hand limit. Then immediately I can say it is discontinuous at x is equal to a. Similarly here, if the limiting value both of them are same, they are equal, then I can write limit extends to a. I can combine and I can write limit extends to a fx is not equal to the functional value. I'll give you the examples later. So the function is discontinuous. Even I will write it is at x is equal to a. Similarly, if one of the limit side, that is left hand limit not equal to the functional value, or the right hand limit not equal to the functional value, then I can say it is discontinuous. If this is a very minor point, so I can write the function is discontinuous. Now I have told I think continuity and discontinuity we are we have done, and I think you have followed it.